Welcome back, students. So here in this video, how to draw image formed by a convex lens. Means with the help of that three rules we discussed in the last video. Using that three rules, we will draw the ray diagrams for the image formation of convex lens. Okay. When you draw the ray diagrams, you have to use a pencil and scale. Then the pencil one should be a sharpened one. Don't use pen to draw the ray diagrams. Okay. So first one, object is at infinity. That's the first one. Object is at infinity. Object is at infinity. We have to draw the ray diagram for convex lens. Okay. So when the object is at infinity, the light rays will pass through the lens and it will focus at the principal focus on the other side of the convex lens. It will pass through the lens and it will converge on the point F2, that is the principal focus on the other side of the lens. Now I will tell you how to draw this ray diagram. Okay. So first one, object at infinity. First you need to draw a lens, convex lens. Draw a thin lens, optical axis, optic center you need to mark here, F1, 2F1, F2, 2F2. From optic center to this one, 2 centimeter you can take. From optic center to F2, 2 centimeter you can take. From optic center to 2F1, 4 centimeter. From optic center to 2F2, 4 centimeter. Okay, 2 centimeter each you can take. Okay, so from optic center to F1, 2 centimeter. From F1 to 2F1, again 2 centimeter. So total distance from optic center to 2F1 is 4 centimeter. In the same way this side also, from optic center to F2, 2 centimeter. From F2 to 2F2, 2 centimeter. So the total distance from optic center to 2F2, that is 4 centimeter. Okay. Now I will just rub all these 2 centimeter, 4 centimeter, all those things. We don't want all these things in our ray diagrams. Okay. So when you construct the ray diagrams for convex and concave lenses, this one you should keep in mind. Okay. Total distance from the optic center to 2F1, that is 4 centimeter. From optic center to 2F2, that is also 4 centimeter. At the mid you have to mark F1 and F2. Okay. Now the object is at infinity. In this case the object is at infinity. Object at infinity. So normally we will not draw the object. Object at infinity. So we will consider the light rays from the object which is at infinity are parallel to the principal axis. We consider the light rays from the object which is at infinity are parallel to the principal axis. So we will draw light ray parallel to the principal axis. We will draw light ray parallel to the principal axis. Light ray parallel to the principal axis. light ray parallel to the principal axis. So, it will pass through the lens, refraction will take place, refracted ray will pass through the principal focus on the other side of the lens. So, this ray will bend downwards and this ray will bend upwards. These two rays will pass through a point on the principal axis and that point is known as a principal focus. Okay. So, these two rays will refract and the refracted ray will meet at F2. So, here you will get the image. At this point you will get the image. So, in case mirror we wrote position of the image, size of the image and nature of the image. Here also we need to write that. Okay. Image. So, we will write it like this. Image, position. Where you will get the image? Okay. You got the image at F2. At F2 you got the image. Where the refracted rays meet or intersect. Here the refracted rays intersected. So, at that point you will get the image. So, position of the image is at F2. Now, size of the image. Size of the image is point size or highly diminished. Point size or highly diminished means very small. Highly diminished. Point size or highly diminished. Now, you need to write about the nature of the image. Nature of the image means two types of images will be formed. One is real and the other one is virtual. So, here in this case it forms real and inverted. Real and inverted. Real and inverted. So, that is the position of the image is at F2. Size is point size or highly diminished because a small image of the object will be formed at the principal focus. Okay, that is F2. The nature is real and inverted. When I told to mark in a paragraph in a textbook, that is when what will happen when sun rays pass through a convex lens, and if you hold the paper for a long time, it will catch fire. Actually, here the object is at infinity. We consider sun as the object. So, the light ray from the sun is parallel to the principal axis and it will pass through the convex lens and a bright spot of the sun, a bright image of the sun is formed at this point. So, that is a principal focus. So, bright clear spot of the sun that is formed at F2. Okay. Then, if you keep it for a long time, if you keep the paper for a long time without disturbing the lens and the paper which is placed at F2, after some times it may catch fire. Okay, it may catch fire. So, that's a first ray diagram. Okay, first ray diagram. When you draw it in the same way, you have to draw it in your notebook. The diagram should be drawn in one page. Okay, one page you have to draw it in your notebook, just like this one. One page, one diagram. You have to write the heading, draw the ray diagram using a pencil and a scale, then write the position, size and nature of the image. Okay, that's in one page. Okay, so next diagram. Here the object is beyond 2F1. The object is beyond 2F1. Actually 2F1 means that is the center of curvature. 2F1 means the center of curvature. 2F2 is also the center of curvature. Two center of curvatures are there for the lens, that is represented by the letter C1 and C2. So 2F1 means C1 and 2F2 means C2. Okay. In your textbook it's given 2F1 is C1, 2F2 is C2. So the object is beyond 2F1. Okay. Then first rule we have used, a ray of light parallel to the principal axis. After reflection, it passes through the principal focus on the other side of the lens. Second rule, a ray of light passing through the center of curvature will not suffer any deviation. Okay. So minimum 2 rules should be there to construct the ray diagram, or 2 light rays should be there to construct a ray diagram. Then only you will get the image. Okay. Now, when these 2 refracted rays meet, okay, where that 2 refracted rays meet or intersect, at that point you can draw the image. Okay. So first rule, when a ray of light parallel to the principal axis, after refraction it passes through the principal focus on the other side of the lens, and a ray of light passing through the optic center will not suffer any deviation. Will not suffer any deviation. Now I will tell you how to, I will show you how to draw this one. Okay, that is the second one. Object beyond 2F1. So first I will draw the lens, optical axis, optic center, F1, 2F1, F2, 2F2. Yeah, I am doing it without taking the measurements. When you do it, you have to take the measurements, 2 cm each. Okay. Distance between optic center and F1, 2 cm. Distance between optic center and F2, 2 cm. Again from F1 and 2F1, 2 cm. F2 and 2F2, 2 cm. Okay. Now, you need to draw an object beyond 2F1. Name it as AB. Name it as AB. Now, a ray of light parallel to the principal axis. After refraction, it passes through the principal focus. A ray of light parallel to the principal axis. After refraction, it should pass through the principal focus on the other side of the lens. Now, a ray of light passing through the optical center will not suffer any deviation. A ray of light passing through the optical center will not suffer any deviation. Where that 2 rays intersect. Okay. Where that 2 rays intersect, at that point you will get the image. So, at this point you will get the image. At that point you will get the image. Normally you will draw the image in the inverted way like this. Okay, inverted way like this, A dash, B dash. Normally at this point you can draw the image. It's an inverted one. Because I am not doing it with pencil and scale, bending is not properly. Okay. So, I will get the image here itself, but the size of that image is not the same way. So, in this diagram it is given clearly. This one is the object and this one is the image. Okay. This one is the object and that is the image. Here the image size is diminished. Okay, image size is diminished. So, here after this one, you have to write it like this. Image position you will get it here. Here you will get the image. This one is an image. So, between F2 and 2F2. The object is the image is between F2 and 2F2, F2 and 2F2 or 2F2 and F2. Okay. Now, size is diminished one. When you do it with pencil and scale, you will get it as diminished image. Here I am not doing it with pencil and scale. Okay. That's why the size of the image is not the same one. Okay. Size is diminished one. Nature real and inverted. Nature real and inverted. That is the nature of that image. Image is real and inverted one. Next one, the object is at 2F1. The object is at 2F1. Okay, the object is at 2F1. The object is at 2F1. So, here only two rules we will use, the same two rules we will use to construct all the 6 ray diagrams. Okay. So, first ray, a ray of light parallel to the principal axis. After refraction, it passes through the principal focus. A ray of light parallel to the principal axis. After refraction, it passes through the principal focus on the other side of the lens. A ray of light passing through the optical center will not suffer any deviation. A ray of light passing through the optical center will not suffer any deviation. So, when you draw it, you should get the image at 2F2 itself. When you draw the image, you should get the image at 2F2 itself. Okay. And one more point, the size of the image is same as that of the object. Height of the image and height of the object is same. Okay. Height of the object and height of the image is same. So, normally you will take the height of the object as 1 centimeter. Okay. 1 centimeter you can take as the height of the object. Okay. In all cases, if you draw an object, you can take the height of the object as 1 centimeter. So, here you will get the height of the image as 1 centimeter itself. Okay. So, you will get the position of the image at 2F2. Position of the image at 2F2. Size of the image same as that of the object. Size of the image is same as that of the object, and nature real and inverted. Real and inverted. Okay. So, 3 ray diagrams we did in this video. First one, when the object is at infinity. Second one, when the object is beyond 2F1. Third one, when the object is at 2F1. Okay. Complete the ray diagrams in your notebook. Okay. Thank you.